Hey, what's going on, everybody? Thanks for showing up tonight. Glad to see we got a lot of people here. So, today we're going to go through and do a full walkthrough of the entry-level pen testing lab that I put out about a week ago. This is a pretty cool lab that I spent a lot of time developing, and I'm really excited to dive right into it. So, let's see. If you haven't seen already, you can basically just import this lab template right into Snap Labs. I've got this pulled up here. There's a link in the description. You basically just go ahead, click that lab template in Snap Labs, import it into your own account, and you can have this lab up and running in your AWS account. It's totally free. The only thing you're paying for is your own AWS hosting, and there's some approximate pricing in the description as well. So today we've got 6 target machines that you can see in Snap Labs here. We have basically these 6 here, everything besides the admin box and the Kali machine. We've got a quick network diagram here if you haven't seen the lab before. Essentially, we've got an edge subnet with 2 targets, which are Web 1 and Web 2. And then we have an internal subnet with 4 targets, Server 1, Server 2, DB1, and DC1. So by the end of this, we should go through, have a few Linux machines compromised, a few Windows machines compromised, learn some pivoting techniques, and run through a small Active Directory environment. Now, what I did is I've got the Kali machine here, just clicked on this button, and we've got a VNC session right into the Kali machine. So from here, we should be able to hit the machines on the edge subnet. So let's see, let me just go through and change this a little bit. It's been a while since I messed with this. There you go, preferences. I want to get the opacity, the transparency gone. That drives me absolutely crazy, especially when you're taking screenshots. There we go. Great, and we'll bump this up a bit so we can actually see what we're doing. Now, of course, the first thing I would do is some port scans against our edge subnet, since these are going to be the first machines that we're going to be targeting. Also, I do want to say I'm going to be taking a pretty direct route to go through this walkthrough, although I do want to talk about a lot of the common pitfalls and things that I've seen, common mistakes and some learning objectives there. So let's go ahead and grab the IP addresses of our web servers. We have 10.10.10.181. We'll start an Nmap scan with that. Nmap 10.10.0.181, and we'll just get all ports running on there. And let's go ahead and do that in another tab. We'll get the other web server, which is 103. So nmap-p-10.10.0.103. So we'll get a port scan going in those two. We can see with this 181 device, we only have ports 22 and 80 open. So if we take this, and I'm going to grab Firefox, see what kind of website is running on that. Let's see. It can be a little slow to pull these up sometimes. See the other port scan's going. Great. So then this other web server has ports 21, 22, 80, 443, and a couple other ports open as well. Wow, Firefox is taking forever to open up. Let's try that again. I see the little wheel spinning. There we go. Maybe 2 Firefox windows. Okay. Cool. Awesome. So let's see what's on both of these web servers on port 80. So we see right here, we get a page that says, we're very proud of the open source work created by our company. Click below to see all of our open source work. Click on show me the goods. And we get a message that says connected to database. And it looks like an array that gets spit out with some sort of name, a location, and an author and access level of public. So what I would do is take this website here, which is pointing to our other web server, and paste that into the browser. Oh, I always said Control-Shift-C instead of Control-C. It's a bad habit from the terminal, I guess. Great, so we'll copy that and paste it in here. We get a bad cert. It's okay, accept that risk. And let's see what we get. Great. So we're presented here with a Git Lab page. So, it's not very uncommon for companies to have their own, GitHub repositories or even host their own GitLab servers. And a very common issue that you'll see with this kind of stuff is sensitive information getting put into repositories. So anytime I am going after something that's an open source project or a company where they have a known GitHub repo, I would always go through and look through all of their files and see if you see any like plain text credentials, API keys, and stuff like that. It sounds kind of crazy, but it works more often than you think. It's very easy to commit the wrong thing, leave some information there that you didn't intend, and get some credentials or something out of it. But if we take a look at this stuff, this is a getrepos.php script, and this is exactly what we were seeing on the other website where it was, pulling all that open source locations for this company, right? But we don't see anything in here. It looks like the database, the username and password are all blank in here. But another thing to check is the commits. So we can actually see all of the different changes in a public repository by looking through the commits. Now, there's ways to squash these commits to get rid of them, but this is another great place to look for some information leakage, right? So we could go through and look through all of these commits here to see what was added and deleted in all of them. So this one's called add new file. We can see that index.html is a brand new file, and here are the 10 lines that were added, right? So if we go back and look, this one in particular, update getrepos.php, we see that this is a case where some developer had pushed the credentials to a database to the Git server, and then they tried to revert that by committing what we see here with redacting that information, but that's still stored in the commit history if you don't squash them. And that's another common pitfall when working with public repos, is you see this kind of stuff going on. So right now we've got the SA credentials to a database, which looks like it is at this IP address. And this 10.10.1.0/24 network, that's the internal subnet, so we can't connect to it. So right now we know we have some credentials, but there's no way we can really use them. So one thing you could do is try to log into this Git Lab server with these credentials. You could try that stuff, right, for password over usage. You could try these credentials over SSH. Basically try these credentials everywhere you can stuff some credentials in, right? I know right now that's not the path, so I'm not going to go through doing all that, but that's certainly something you should do if you find some credentials that you think are valid. So we found those credentials. Now let's go back and look at our port scans. So we looked at this web server. All we have open is SSH and port 80. We already checked the web server that's hosted there. We have port 80, 443, 21, and 22, 8060, and 9094 on our other web server. And I think 103, is that web 2? Yeah, it's web 2. Great. So we saw what's on port 443. That's the Git Lab server. Let's see. Let's take this IP address. This is web 2. Now we saw that port 80 was open as well. So let's go ahead and browse with regular HTTP. We'll go to port 80. And you see we get a different page. This is the default Apache landing page. So an important thing to note here is that just because you see ports 80 and 443 open on a box, that doesn't mean they point to the same location. When you're configuring a web server, you can have these different ports with HTTP and HTTPS point to different locations. So although they may be the two web ports on the same web server, they might not be pointing the same application. And in this case, that's what it looks like. Port 80 points to an Apache server. Port 443 is pointing to our GitLab instance. Alpha Cybersecurity, hey, what's going on? Thanks for stopping by. I appreciate it. Awesome. So we got a little enumeration there. Of course, when you see web pages like this, it can be good to go through and brute force web directories with GoBuster, Dirbuster, tools like that. You could check all of the versions and get that stuff going as well. Now, another thing that is very interesting to see open is port FTP. Now, again, from this perspective, we're on the edge subnet, which is kind of simulating external access, so things that would be publicly available to the internet. Now, it's not extremely common that you'll see companies with FTP servers exposed to the public internet, but it certainly happens. Especially with large companies, you can have a lot of, kind of skeletons hanging around, and inventory management can be really tough. So it's not uncommon necessarily to see FTP servers exposed to the public internet. I believe, if I remember correctly, that's part of what happened with the SolarWinds breach, was a public FTP server with some weak credentials. I think so. But when I see these FTP ports open, the first thing I want to do is open a connection to it, right? So we'll do open and the IP address, and then try anonymous, if I can spell it, anonymous access to that FTP server. In this case, we see login successful. So we now have FTP access to the server from an external, internet kind of standpoint, and that's kind of a big red flag. Now, one thing that is interesting with this is that we can see that we have the index.html. And if we were to actually get this index.html and download it, let's see, we do get index.html. Perfect. So now if we open up a new tab, we'll just check out what that is. Oh, perfect. So let's take a look at index.html. And if you were to look through this, you'll see that this is actually this page right here, the Apache 2 default page. Now, that is very concerning because that means we have anonymous FTP access to the root of the web server that's running on port 80 on Web 2. And it's, a very common technique to see these kind of file hosting servers and a web server on the same device. And this kind of stuff was really common, these kind of attacks where you could log in with weak credentials or no credentials, compromise like WordPress sites or things like that. It was really common, I don't know, probably 20 years ago, but it still does happen today. A lot of times if you go register a WordPress server or some random, hosting server, you will have FTP access to it as well. And if, someone who is not too experienced is setting that up, it's not very uncommon to see a mistake like this. But anyways, if we try to put a file here, so let's try to put that index.html file that we got, and we'll put it as index1. We could not create the file. And that's because we don't necessarily have upload permissions to this FTP server or this directory. But we see this temp directory right here, right? And we can see that we have read, write, execute for everybody. So that's basically 777 permissions. So if we were to cd into this temp directory and we to run that put command again, we'll just call it index1.html. It completed. So if we go back to our web browser and browse to /temp/index1.html, boom, it's the same page. That's the file that we just uploaded. So from here, the first thing that would come to mind to me is putting some sort of PHP Reverse Shell on there and trying to get a connection back to our device. So let's see. I know Kali has a bunch of built-in PHP shells, and let's see, they are stored in user share web shells. Yeah, web shells. There we go. And PHP. And then the one I like to use is PHP Reverse Shell.php. And we'll just put this in our current directory. Let's get our IP address. Sorry if my typing's a little weird. I just got a brand new keyboard and the keys are a little touchy. So there we go. We'll get our IP address. Let's go ahead and edit this PHP Reverse Shell. And we will put our proper IP address in here. Great. Cool, we'll paste RIP. I'll leave the port as 1234. That should work in this case. Although note, if you're working in some sort of, real environment or something that has a firewall, then you're probably not going to get port 1234 outbound. I would still just send it over port, 443 or 80. In this case, it doesn't matter, but just keep that in mind for if you're doing something that's a more realistic environment. See, Snap Labs is a goat. I'm 7 hours ahead, so I got to run soon, but thanks for all you doing. Thank you so much. I really appreciate that. Yeah, Snap Labs is really cool. I have really enjoyed building labs with it, and it seems like people have been loving it so far. So I think I'm going to keep building some more labs, and we'll have some more scenarios coming up as well. All right, so we have our PHP Reverse Shell. Now let's just start a netcat listener. We'll do netcat LVP, port 1234 is what we chose. Let's go back to our FTP server. Make sure we're still in that temp directory. Yep. And let's just put our PHP Reverse Shell.php. We'll just call it shell.php. And there we go. That is sent. So now if we just browse to that in our web browser, let's see, we called it shell.php. Perfect. We see this, kind of loading. The page never renders. That's a good sign. We go back and we have a shell. Now if we do a who am I, we are www data. So now we have our first low privilege shell on this environment. We have gained, this low priv access on an external server, but that's certainly a step in the right direction. Now, the first thing I want to do here is get a more stable shell. We should get a TTY session. It just makes things a lot easier. You can do this with Python. If you do Python 3-C, import pty, pty.spawn. Let's see, and then we'll do bin bash. So this is basically spawning an interactive bash session with Python. Boom, there we go. Now we have something that's a little bit more stable. See, thanks, super helpful for OSCP. Awesome, thank you so much. I'm glad to hear. And this little Python trick here, that's something I learned while going through OSCP. It was super helpful because I think, at least when I did, I think you had to have interactive sessions, and this was the way to do it. If you're trying to do anything with sudo without an interactive session, it just won't work. And it's a super common privest method, so I would always do this when you get a low priv shell that looks like this. So the first thing I would do when trying to privest on a Linux box, I know a lot of people will go right for the scripts. First thing I do, low-hanging fruit, check sudo. So do sudo-L, it asks for a password, we're out of luck. So that's unfortunate. But there are a ton of different ways to enumerate privilege escalation, right? You can use all sorts of scripts like linenum. I also put out a checklist. Let me pull that up real quick for those of you who haven't seen it. github.com, go to my GitHub, and I'll show you guys something cool. I put together some mind maps for OSCP privilege escalation. It's really helpful for things like Hack the Box and, specifically OSCP. If you haven't seen this, go ahead and check it out at my GitHub. Essentially, I just listed out a bunch of different common ways that you can privest in OSCP environment. Or, OSCP related stuff like Hack the Box, Try Hack Me. And I refer to this myself all the time because, it doesn't list out how to do everything. It's more of like a mental checklist, like, oh, did I remember to check for services running on localhost once I got a shell or whatever, right? So I have it for both Linux and Windows here as well. So I am a big fan of using automated privilege escalation scripts for this kind of stuff. Specifically, the one that I use the most often is linenum. Now, typically you just transfer that onto the box, run it, and see what kind of output you get. In the interest of time, I'm going to show what the interesting output of linenum would be. Let's see, I don't think we can clear this. No, we can't. That's unfortunate. So the first thing I'm going to do is we'll go into, well, there we go. Sorry, I hit tab on accident. It's just a force of habit. Let's go into etsy/cron.d. Now, if we were to run linenum and go through all of that, we would see an entry in the system cron directory. So if we do an ls here, we see this timestamp cron job that's being run, and that is not a standard cron job on a system, so that stands out automatically, right? If we do an ls-la, this is owned by root, and it's readable by everybody. We don't have write access to it, though. So, we can't overwrite this cron job and exploit it. But let's just take a look at what this is doing. Let's see, it looks like it says server keeps shutting off at night, need to log what time it powers off. So we have this cron entry. The syntax of this, basically these, if you were to plug them into like a cron time calculator, it's saying basically just run every minute. This is the user that it runs as. So it runs as the user Brandon, and it runs this script, etsy log time.sh. So that's interesting because that's certainly not something that's standard. And when you're doing privilege escalation, the first thing that I do is look for things that are not standard. Because if you look at these OSCP boxes or lab boxes or even real machines, if you can identify the delta between the current state of the machine and the base image, usually some sort of misconfiguration or exploits lie in between there, unless it's some 0-day in the operating system, right, or something like that. But any installed software, change permissions, new cron jobs or configuration settings, that's usually where the problems are going to arise from. Great. So let's take a look at what this log time script does. It runs bash and it runs time.datectl and outputs it into temp timestamp. So it kind of does exactly what was noted there. But if we do an ls-la of this, we can see that the script that this cron job is running is actually writable by everybody, and it runs as the Brandon user, which is a different user than www.data. Not necessarily higher privileges, but usually users are more privileged than what the web server runs as. So that's certainly something we should look into exploiting. So in order to do that, we are going to have to overwrite this script here, or at least append to it something that could give us a reverse shell. Now, the easiest way to do this is to just echo a line in there for like a netcat reverse shell or Python reverse shell, whatever you want to do, right? In this case, I am actually just going to use the same exact PHP one that we had on there before because I'm kind of lazy and don't want to go through uploading another one. So I'm just going to start another netcat listener on port 1234. I know that seems a little bit weird since we are currently in a shell that we spawned from port 1234, but since that's already bound, we have no problem trying to listen again. What I'm going to do is we have our reverse shell that we uploaded here. Let's go ahead and find that. That is going to be in /var/www/html. We know that's where the FTP server pointed, right? And then we have our temp directory, which is where we uploaded that reverse shell. And there it is, shell.php. So what I want to do is just tell that cron job that runs as Brandon to execute that PHP reverse shell. So we'll just do echo PHP /var/www/html/temp /shell.php. Let's see. That should execute that reverse shell. And we want to append that into /etc/log-time.sh, which is that cron job that is running every minute. We run that. Great, that should be working. Now, hopefully, once we hit another minute, the cron job should run, and we should get a reverse shell as the Brandon user. Hopefully, we'll see what happens. But hey, while we're waiting, we're just kind of killing some time. I do want to say thank you. There's definitely a lot of people showing up tonight. I really appreciate it. I hope some of you have been able to start working through the lab. I know that I had a ton of fun building it. I had a lot of people testing it before it went public. Everyone seemed to really enjoy it. I've also had a few people complete it since it's gone public. So, I hope it's really helpful. And I like that Snap Labs has given us some sort of platform where we can offer this stuff for free and, just kind of pay the hosting fees. Great. So it changed to 6:22 p.m. here. That cron job ran again, and now we have a reverse shell. We do a who am I? We are Brandon. Now, again, first thing I want to do here is get a more interactive session. Let's do a python-c import pty.spawn, and let's spawn a session of /bin/bash. Oh, Python's not on the box. Yeah. So this, you'll see this sometimes. I just forgot to say Python 3. There we go. So now we have a session as the Brandon user, which is most likely higher privilege than www data. Now, actually, one thing I forgot to say at the beginning of this stream is that I built this lab in a way that there are no exploitable, well, the intended exploitation path of the entire lab does not contain anything that relies on CVEs. So this entire lab is built on the premise of misconfiguration and lazy administrators, which I think is a pretty cool concept. I know that CVEs are certainly a big part of what's going on when you're exploiting something, but I think that it can be kind of simple to, look up a version number, pull something off exploit.db or GitHub, run the script, right? I didn't want anything like that in here. Plus, it's a little bit harder to maintain. So there's nothing like that in here. It is all based on misconfigurations. Give me 1 second. I turn my speaker on. I see people subscribing. Thank you so much. I'm just not hearing the notifications. Give me 1 second. Great. All right. Sorry that my speaker makes a loud sound when it boots up, so I had to mute my microphone. Awesome. So now we have a shell as Brandon on Web 2. First thing I do again is sudo-l, and we are prompted for a password that we don't have. So again, sad day for sudo privilege escalation. Just not going to work in this case. I'm just going to hit enter to get through all of this. So you could go through and again run linenum here, try to privesc to root, but spoiler alert, there is not a way directly to get root from Brandon just on this box. And this is where the lab starts to take a turn from what you may be used to in just exploiting hack the box machines or OSCP lab machines, and the fact that you need to attack this lab as a whole environment. Remember, this is like a a mock corporate environment or something, right? This is not just a regular attack one box at a time and then move to the next box. In this case, you cannot get root without going to another box first, and this is where the fun really starts to begin. So I think the initial part with the Linux boxes is pretty easy. It starts to get a bit harder as we move internal, which is intentional. It kind of ramps up the difficulty. Now, if we do, let's go to Brandon's home directory. Let's do an ls-la. One thing that you should see in here that kind of stands out is we have an SSH file. An SSH directory. Let's go into there, and we see that Brandon does have a private key here. So, and if we cat the authorized keys file, it is, already authorized to SSH in with Brandon. So what we can do is just steal that private key and SSH in for a much more stable shell. So I'm just going to cat our ID underscore RSA. Great. And let's copy all of this. Man, I guess I'm too quick with the copying. I gotta try that again. Let's see. Cool. Now, take two. Try to copy all of this. Man, this might be the hardest part. Just trying to copy this. We'll go from the top down. Maybe that's smarter. Man, this is that's something, huh? One more time. We're getting a little lag in the VNC session, so it's making it tough. I have excuses for days. Perfect. I got all of it except that one dash, so I'll just remember that. So now let's just open up a new tab again. Great, great. Let's we'll just call this key.pem. We'll put our dash in there, paste the rest in. We should be good. I'm going to change mod this key to the appropriate permissions of 600. We should probably specify the file name as well. And now we should just be able to SSH in Brandon at 10.10.0.181 was the device. Do the -i for the key, and it will be key.pem. Hey, William Frank, glad to see you in here, man. Thank you. Long time no see. All right, we'll accept this fingerprint, and we should be able to SSH right in. Great, we are in Web 1. Fantastic. Now see, oh, we're working in Web 2. Well, that brings us to our next point. I botched, oh wait, let's see. Yeah, what IP was this? Oh, this was Web 2. Yeah, okay, so I botched that, my bad. This was supposed to be 103 that we were going into. That's okay, that's intentional. That was the next point. There we go. Well, SSH into 103, which is Web 2 we're working on. Now, the next thing that you would do, again, is I know just because I built the lab that there's no way to get to root. I expect people to try to do that and unfortunately fail. But, life sucks sometimes. That's what happens. And now you would want to start branching out to other boxes, right? And the other machine, the other web server that's on the edge, we don't have much to go off of. We have port 80 open. We have port 22 open. We can start to hit internal devices now as well. So there's two paths you can take here. You can go for the other edge machine, or you can start going internal. We have what we need to do both. So let's see. William Frank saying, saw the announcement at the labs, looks quite cool. I've stepped down a bit from pen testing and stuff, doing more CTFs and learning binary exploitation. Hey, that's awesome. That sounds like a lot of fun. I wish I had more skills in that subset, but unfortunately not. Yeah, so, now we want to start branching out to other devices. One of the huge things that you'll see in, potentially in organizations or whatever, right? It's anything that's done at scale is password reusage. It happens almost everywhere in some way, shape, or form. It's just human nature. People create, the same password, use it even just for two things, right? It could just be two things. Or in this case, they use one private key that works in multiple machines, which is also, unfortunately, a fairly common thing to see. So now that we have this SSH key, the first thing I would do is try to SSH into another Linux box with it. So if we just SSH into, well, I'm going to kill this session. We already know that we can SSH into 181, which is Web 1 with it, because I did that, but that's what's happening there, right? We have a reused SSH key, again, which is just a form of reused credentials, which gets us into Web 1. Awesome, right? Now we have a low privilege SSH session to both of our edge machines. We can either go for root on these or start pivoting internal. And let's do this one, sudo -l. You could, and someone prompted for password or sudo. We can't do that. You could run linenum on here, and again, you're not really going to see anything, hopefully not, unless I screwed something up, but you won't see anything that's going to get you to root, and now is where people might start to get stuck. So what is intended from here is to start pivoting internal. Let's go ahead and take a look back at our Snap Labs network diagram. We have Web 1, Web 2, boom, low privilege shell, we got SSH access. Now we want to go to this 10.10.1.0/24 subnet, start hitting up these devices right here. Now, pivoting can be a little tough if you haven't done it before. There are a lot of different tools that you could use for it. Some work better than others, but some are easier than others. The one that we're going to be using here is called S-Shuttle. Essentially, it is a way to do a lot of like SSH tunneling, really. It also kind of works as a proxy as well. Essentially, instead of having to port forward individual ports over SSH to one specific port on a remote machine, it'll do it for like a whole subnet or all the ports as well for us. It just makes things a lot easier. But unfortunately, some tools like Nmap won't work through it. It'll work, but you'll get every port coming back as open, which is usually not true, right? You could run proxy chains and get some more reliable information from like Nmap scans and stuff like that. It's just a little bit more difficult to set up, not by much, just a little bit. In this case, we're going to use S-Shuttle. I've done a whole video on this as well. If you're not too familiar with it, well, we're going to use it here, but you can also check that video out as well. Now, I'm just going to do an apt install S-Shuttle from our Kali machine. I believe it is in the mirror. Let's see. Potentially. Sometimes trying to install stuff in Kali, especially if it has to do an update, will take forever. Or in this case, reading the package list, because Kali has 8 billion packages. All right, almost there. Great. That's installing. And we should be able to use this with the SSH session that we're able to establish as the Brandon user with that key to start pivoting internally. Any day now, though. And please, if you have questions at any time, if you want something explained in more detail, please stop me. Feel free to ask questions. It's all about learning, so there's definitely no shame in not knowing something. I'd rather people, ask if they're uncertain about something. And if you can't make it for the whole stream, totally understand. We'll probably be going for a few hours, but I'll be posting an uploaded recording after, as always, as well. Sorry. I can't drink water. I'm just drowning myself. Don't worry about me. Yeah, I probably should learn how to drink from a cup better. It's all good. We'll survive. All right. So now we have S-Shuttle installed. So if we were just do S-Shuttle -H for help, we should see, all of the options that we can use here. Essentially, what we need to do is, let's see, did I give you an example usage? Excuse me, I'm just got a lot of water down the wrong pipe. I don't think we have. Oh yeah, usage right here. Great. So basically what we need to specify is the remote, which is the server that we're going to use as a proxy. So in this case, we're going to use Web 2, and we are going to forward all of our traffic for the 10.10.1.0/24 subnet through Web 2, because Web 2 can hit the internal stuff, but we cannot from an external standpoint. That way we can, run whatever tools we want, get them tunneled through that edge node and into the internal subnet. So very common pivoting technique, and S-Shuttle is a very easy way to get this done. So what we want to do is do S-Shuttle -R Brandon at 10.10.0.181. I believe it's Web 2, right? 103 is Web 2. Which one had the web server running on it? So in this case, the reason we're targeting the server, we're going to do 181, is because we see that this is connecting to a database, an internal database based on that GitHub repo, right? We saw it was connecting to something with the IP address 10.10.1.1.1. So based on that logic, we can infer that this must be hitting that internal device. Therefore, it must have the network access to hit that device in some way, shape, or form. So we want to send our traffic through this IP address, 181, that's Web 1. So we want to go through Web 1. And I think I had 181. Yes. Okay. Just making sure. Right. So our remote is Brandon at 10.10.0181. We need to specify the I flag as well, which is basically the SSH arguments. So we're going to do SSH, I'm sorry, the E flag. And for this, we're going to do ssh-i key.pem because instead of using a password, we're using the SSH key. This is telling S-Shuttle to use this when it invokes SSH, use this argument. So we can run that. Let's see, what are we missing? Yes. Oh, the subnets. I'm sorry. We need to specify what subnets we're targeting. So once we specify the subnets, whatever traffic from our Kali machine is destined for that subnet is what's going to be sent through this S-Shuttle session and ultimately sent through Web 1 to hit that internal subnet. So in this case, it's going to be 10.10.1.0/24, and that should work. Connected to server. Great. So that should be working. We should now be able to hit machines that are on the internal subnet. So let's see. Our database server is, let me see, I'm going to kill this. We don't need this session anymore. Great. We might be able to ping it. 10.10.1.111, I believe, is our database. I think discovery is turned off for some of these, so we can't actually ping them. Let's see. The domain controller is .100. Can we ping that? Nope, we can't ping anything. That's okay. Let's see. Well, we know, basically, that there is a database server. And we have credentials, potentially, to that database server based on that Git commit that we found earlier, right? We see this IP address here. We see this database, Git Lab, the UID SA, and the password is very, very secure 1. So what we could do is we can run Nmap. We should get results. I believe the port is 1433 for MS SQL. Let me see. I don't remember ports very often. 1433, yeah, it's one of the standard ports for TCP. Okay. So if we do that with and detect the server's version on 10.10.1.111, we should be able to see some more information about that MySQL server. No, it's down. Turn ping checks up. Ping checks off. Filter. Interesting. Okay. So it's not letting us hit that. Now let's try. Maybe we need to go through the other host. Let's try again. Sorry. Let me reference my notes here. I might have screwed something up. Connected to server. All right. Now can we do that? Another thing we could do is SSH into the boxes and see which ones it can hit. So if we were just to SSH in, let's see, we'll just do SSH Brandon at 10.10.0.103 with our key.pem. Right, and let's see if we can ping 10.10.1.111. Nope. So now we will exit out of this and we'll go through and we'll go to 181 instead. Great, and now let's try to ping it. And it's very possible that we just might not be able to ping because host discovery is turned off. This allows us to ping. Great, yep. So Web 1, it is allowing us to ping. It looks like just with S-Shuttle, we're having some issues getting that working. But let's make sure I have the correct arguments. Yep, that looks correct. Okay, yeah, so again, we can just have some discovery issues with the S shuttle stuff. Proxy change is much more reliable for doing that kind of thing, but it should still work for our exploitation stuff. So in this case, we know we have the database credentials and we can hit the database now through that S shuttle session. Although Nmap is not saying that we can, we still should be able to. Now, the first thing I want to do is connect to that MySQL database and take a look inside, see what kind of information is in that. You could get the MS SQL command line tool for Linux as well. That is one way to do it. Personally, I just found that a huge hassle to get up and running. It really was a big pain. So I'm just going to use Metasploit to do it. And Metasploit has a module built in to connect to MySQL servers, and you can just run regular queries on them that way. It's a lot of overhead to run SQL queries, but it is pretty simple because it comes pre-installed on Kali. I am curious why that is saying the port is filtered, but that's okay. Start up our Metasploit framework. Good old Metasploit. We'll be using Metasploit a fair amount here, just because I think Metasploit is pretty cool. I know I know most people will be familiar with Metasploit, so I like to stick to using this kind of tool for the walkthrough, but you could really use whatever kind of tools you want through this. You don't have to stick with these. So we're going to use auxiliary admin msql/msql_SQL, which should allow us to just run SQL queries. So we'll use 20, and let's see our options here. Great, so our remote host, so we'll set our host to 10.10.1.111. Great, we'll set the password, and let me go grab that password that we found in our Git commit. There we go. And our username is SA, that's great. And let's see. By default, it's just going to try to select the version, so let's try that, and then we'll run it. So hopefully, this should proxy our traffic, and we should be able to run this query against that MySQL instance. We're getting hung up there. Not exactly sure why. 10.10.1.24, that should work. Says it completed, but it did not give us anything back. Make sure our options are correct. Yep, that seems to be working. I'm wondering if we are having some issues with S shuttle. Interesting. I feel like there might have been a version issue with S shuttle. I feel like I might remember that from testing, although I don't recall exactly. So see, it's accepting that. What is going on there? Sometimes we run into issues. Let's see. That's sure. Capital R. Do we need the capital R? Let's see. Is there a difference? It says lowercase. We'll try the capital and see if that works. The syntax seems correct. Yeah, it still wants the lowercase r. Good thought, though. I'm wondering... Interesting. Well, we know... Oh, no, no worries, dude. I'm wondering why that's not working. That's always fun. That's the perks of live demos, right? We'll get a little troubleshooting in, but it's good. I mean, if you're going through this lab, you might be running into the same issues. I am not exactly sure what S-Shuttle's issue is here. Let's look through some of these logs, see if anything shows some sort of error or issue. Let's see. I wonder if we can install a different version of S-Shuttle. I'm trying to rack my brain here and remember what was going on. I feel like the version that we can install with pip might have worked better. Let me try that. Let's try that. So the we don't need sudo. The biggest thing is trying to get tools to run. Do you have to run with proxy chains? No, you shouldn't have to. I didn't use proxy chains at all when I wrote the walkthrough for this. Oh, did I just screw up the syntax? Let's see. That's very possible. That sounds like something I would do, is mess up the argument orders. Saying put the subnet at the end. Okay. Okay, so we'll put the subnet at the end here. That is very possible that that's the issue. I hope it was. Let's see. Let's exit out of this. Let's try that quick Nmap for port 1433, just because we know that that database is open for 10.10.1.1.1. Seems down. Let's see. I want to keep seeing the walkthrough, but gotta go. Oh, no worries. Thanks for stopping by. And like I said, the recording will be posted after, so not a problem at all. Yeah, what is up with that? Yes, the live will be on the channel after. Let's see. We did confirm that. Sorry, I should probably know this since I built the lab, but you know, things happen. It's 10.10.1.1.1.1. Maybe that's what it is. All right. This should be 181, right? Oh, yeah, of course it should be yeah, it should be 181. Oh, I'm an idiot. I think that's what it was. A combination of both. Syntax error, wrong IP address. There we go. Sorry about that. So painful. Thank you so much for the help, George Villa. You saved the day. Yeah, so I went through that whole explanation of why it's this IP address, and then I plugged the wrong IP address in. You know, that's just how it goes sometimes. But there we go, right? So now we have... we can run queries against that internal database because we are proxying our traffic through that edge node that we have a low privilege shell on. Well, SSH access to. So this is the very first step in getting internal access to this network, which is really cool. So we have the version. We know we have those valid credentials. Now what we want to do is start enumerating that database and extracting some valuable information. Now, if you are like me, you can never remember the MS SQL syntax. Don't worry, I have it written down. I just want to show you a very awesome resource. We're going to look at payloads, all the things for MS SQL. Payloads, all the things, if you haven't seen it, an amazing GitHub repository. It'll help you with everything, right? So many different attacks. Now, they do have a section on SQL injection, if I can find it. Great, SQL injection. And in here is MS SQL. Now, the Microsoft SQL syntax, at least to me, is less than desirable. I always forget it, and quite honestly, I just hate it. But you can go through and see a lot of the easy syntax of what you need to know right from here. You know, listing databases, listing columns, listing tables, and that's all the kind of stuff that we're going to have to do. So the first command that we want to run, let me reference my notes and change this. So we want to set SQL to select name from master sys databases. This is going to enumerate all of the databases that are on this MS SQL instance. So here we see we have master, tempdb, model, msdb, and Git Lab. Git Lab was the one that we saw being referenced in that Git Lab repository, which was, you know, pulling some code out for, you know, the web server. So I want to start looking into that. So let's take a look at what tables are in that database. So we'll set SQL to select name from gitlab.sys objects where utype is equal to u. And if you don't know how to, you know, find this kind of stuff like this syntax, I got it all from here. Like, here's the exact query that I'm running. I just grabbed it from the payloads, all the things, repo to list tables, right? That's always my cheat sheet for this. We can run that, and we see we have two tables here. We have repos and users. Now, I think that the users one sounds pretty interesting, so if we keep enumerating there, we'll grab our next SQL commands. I'm going to type all this out. We'll just do select star from GitLab users. That's just going to pull all the information from that users table in the GitLab database. We run it. We see we get two usernames. We get Brandon and Root, and we get their passwords. Big score, right? Now we have query the internal database for some user accounts and passwords. Usually, that leads to a very bad day for the sysadmins, but a great day for us because we got some passwords. So the username Brandon, we saw that before on the Linux boxes. And of course, the root username, well, that could be very well be the root password. In this case, that root password will actually net you nothing. It does not work. Sorry, I had to throw it in there for a little bit of false hope. But if we go back to our Linux machines, let's take a look at 103, which I believe is Web 2. Yep. So now we remember when we try to run sudo, it asked us for a password, and we're running as the Brandon user. So now let's try to do a sudo -l. We'll paste in the password for Brandon. Brandon can run anything with sudo as long as you have the password. So let's do sudo -i. Boom, we got root. So now we have popped and gotten root on the first box. That is Web 2. Great. So that's 1 out of 6 down, and we have a low privilege shell on Web 1 as well as the Brandon user. So we know that the Brandon user reused their private key to go from Web 1 to Web 2. So the chances that they also reuse their password are pretty high. So let's just go ahead and SSH in as Brandon to Web 1. We'll do a sudo -l. And let's paste that password in. Now we get prompted for a verification code. That's a little wrench, right? The password is correct, but we need a verification code. If you don't know what this is, I recently put up a video on how to set up multi-factor authentication on Linux machines using Google Authenticator. And that's what this verification code is. It's prompting us for MFA, which is awful. There's no worse feeling than when you compromise a password and you got to get through MFA, right? So in this case, we do. But if you watch that video I put out on setting up MFA with Google Authenticator on Linux devices, you'll know that there is typically a file in your home directory that is called .google authenticator. And this is a very sensitive file for MFA purposes because it holds the secret to this MFA account, which is this right here. It also can contain some one-time passwords that may or may not work in this case, where you could just enter in these codes and potentially, if nobody else has used them, you can just use that as a verification code. But what will work every time is using this secret to link some sort of MFA authenticator app to this account, and then we can just use the code that's generated. So what we can do is I'm just going to open up Firefox, and we're going to look for the Firefox Google Authenticator application. Great. So we see this Authenticator extension for Firefox, right? I'm just going to add this into here. This is going to allow us to use that Google Authenticator right in our browser. That way you don't have to go and set it up on your phone and all that stuff, right? Great. This should add in just a moment. Hopefully. Man, everything is slow today. I'm going to say it's not my fault. I have gigabit internet. I'm going to blame Mozilla.org for this one. Any day now. All right, let's try. Is there a different place to download it? Let's see. Firefox, Google Authenticator app. Let's see if there's another place that we can download it. That would be my luck that during the live demo it doesn't want to download an extension. Maybe. Let's force a refresh here. Let's see. Let's see if we can just search for Authenticator. It's the same page. It doesn't want to work. That's cool. That's cool. Well, we can still work around this. No problem. I did want to show how to do it. It looks like I'm not going to be able to, which is pretty unfortunate. Let me just kill Firefox and try to start it all over again. We can also get that extension on a different browser. It's no problem. We should be able to. Great. Authenticator. Add to Firefox. Hey, there we go. Just the good old turn it off and turn it back on again. Perfect. All right, so now we see we got this Authenticator extension here. And we can add new things by clicking this little plus button right here. And we can do manual entry. Here we are prompted for an issuer and a secret. Well, that secret we can grab from this Google Authenticator file here, right? We will copy that. Let's go back and add this again. Little plus button, manual entry. We'll just say, entry level pen testing, ELP. Paste in that secret, click OK. And now we start getting some codes generated. And since we have the same secret as this account, these are, the valid codes for this account that we're looking at. So if we were to do a sudo-i, we're prompted for Brandon's password. Let's go ahead and, where did we grab that? From a different tab. Cool, copy that, paste that in there, and then let's go grab our verification code from our Google Authenticator app. Let's copy that and paste that in. Perfect. Now we have root on web 1 as well. Now we've got 2 out of the 6 machines rooted. That's all the Linux machines, and now we start working into the internal domain. We've got all the edge machines compromised completely, and the next logical step is to start working towards that database server, which we already have access to the MySQL stuff, right? We can log in with MySQL and start messing around with it. Now, something that is really dangerous with MS SQL, is that there's the XP command shell option. What this allows you to do is actually execute OS commands from the database. So if you have XP command shell enabled, you can start to run whatever commands you want as whatever user the database runs as. Also, look at this. That's a nice little patch there. Good job, man. Happy for you. Great. Yeah. So we can use that same Metasploit module. Well, a different module. We can still use Metasploit to start trying to execute commands as whatever user that database is running as. So let's just do another. Well, let's see. Let's just look at our options here just so we have that password cache. I don't want to go looking for it again. Let's do a search in Metasploit for MS SQL. Search. There we go. Awesome, awesome. And we want to start executing some commands. So let's go for this one, MS SQL exec. Right, this should do some command execution for us. It will also enable XP command shell for you if it's not enabled, but you need system administrator access, which we do. We have the SA credentials. So let's use this. Let's, I'm just gonna hit up. We'll set our password to whatever it was. We'll set our host to 10.10.1.111. Let's just take a look at our options again. This is going to try to run this command. I don't want that. I want to set our command to just run who am I. Let's see what user the MS SQL database is running as, because whatever user that service is running as, that's the context of what commands, that's the context that will, how do I word this? You know, say if the database is running as administrator and we execute commands from the database, they will also run as administrator, right? So let's just run this and see what we get. Right, it ran very quickly. The output NT authority system. This is big, right? So we know that this database is running as system, which is the highest level of access on the device. And we can execute commands as system on this operating system. Now, typically you'll see a lot of these databases running as service accounts, but they may be privileged. But in this case, it is running as local system, which is a configuration option, and it's not that uncommon to see this happening, right? So I'm going to do another search for MS SQL because there is another module in here that will basically just download a Meterpreter shell, a Meterpreter payload, and run it, and we should get a Meterpreter shell from it. So I think we are looking for MS SQL payload. That sounds awesome. So let's use that. Let's go through and set our remote host. We'll set our password. What other options do we have? Lport, that's fine. Lhost, that looks fine. Okay. Let's check our IP. Let's make sure that's right. Yep. Okay, so let's run this. And this will take, a couple of seconds to run. It takes a while for the stager to get delivered, but not a problem. This is probably what most people would go right to. They see command execution, they say, all right, send that bad boy over there. Give me that Meterpreter session, right? Now, spoiler alert, this is not going to work. At least it shouldn't work. We'll see what happens, but I do want to show some of the common pitfalls when exploiting this lab because it's likely that you may have found yourself in the same situation. So I do want to kind of point some of this stuff out. So we're about 90%, almost all the way there, and we'll talk about what's going on here. All right, stager is completely sent. All should be good. Now the stager should be getting the actual payload, trying to run that, and we get the infamous exploit completed, but no session was created. Soul crushing, right? No worse feeling, really. But the reason this is happening, we at this point we kind of have to speculate. What is going on? Why do we know we have command execution as system, right? System, that's the highest level of access we get. We can run command to system. We ran who am I, that's for sure. We know we transferred the stager over, but why did it not execute the payload? It seems like the payload was delivered, payload was not executed. What could have caused that? Well, it turns out the answer in situations like this is very often antivirus. What is happening here is, yes, we can execute commands as system, but when we send over that generic Meterpreter payload, of course Windows Defender is going to see that and not execute it. It's getting blocked. And if you were to use your SnapLab RDP session and go in there with local admin, you'll see Defender stopping this right now, and that's what's happening. So now we have to start fighting with Windows Defender to actually get our shell as system. And it sounds like a difficult thing to do, but in reality it's not that bad. We're not going to be doing anything crazy like We're not going to be generating a payload even that will bypass Defender. It's easier than that because we have system level access. It's really not that bad. So what we're going to do is go back to our MS SQL exec module. Let me just set our password. We'll set our remote host again. Just clear the screen up. Our options, let's take a look. All right, we have our command is who am I? We know we're running a system. So you can actually run a very small PowerShell command to disable Windows Defender. And since we're running a system, we should have permissions to do that. This can fail if Windows Defender is managed by like group policy and tamper protections on. So, you know, mileage may vary with this kind of technique in a real environment. But with this lab, it certainly should work. So I'm going to just reference my notes here, just grab this command. And let's set our command to PowerShell.exe -c, and then we'll paste in our command, which is set MP preference -disable real-time monitoring true. So that is just turning off Windows Defender real-time monitoring. And we should have the privileges to do that since we're running a system. Type in run. I use the verbose option too, so we should get some output and see what happened. Performing operation, blah, 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 and it completed. So it should be disabled now. Windows Defender real-time monitoring, that should be off, and our payload should be able to execute. So I'm going to go back to our MS SQL payload module. Let's see if our options persist. I think so. What is it using? Windows Interpreter Reverse TCP. Perfect. All right, I'm going to clear this. Let's run it again. Send that bad boy over there, and we should be getting our reverse shell as system now that pesky Windows Defender is out of the way. Hopefully. Let's see. All right, sending the stage. There we go. Interpreter session 1 open. That is what we like to see. Interpreter commands, I can never remember them. Get UID. There we go. All right. We're running as NT Authority system. We have an interpreter session. Awesome. That is 3 out of the 6 blocks is compromised. Now, I will say this next part is what I personally consider to be the hardest logical jump to make in the entire lab. A lot of people tend to get stuck in this next part. CW mistake. Is it okay if I do something like this on a real pen test? Thank you. I'm glad you brought that up. I'm sure you do know the answer, but the big thing to keep in mind here is since we're working in a lab environment, we're not really worried too much about operational security or what state we leave these machines in once we're done, right? When I'm done with this lab, I'm going to turn it off. I'm going to delete all the boxes. It doesn't matter. But to Cody's point, in a real engagement, you don't want to do that. You don't want to just flat out kill your client's antivirus, even on a single node, because that opens them up to real attacks, and that does have real consequences. So typically, you would do some less persistent antivirus evasion, like, really generating a payload that doesn't get caught, or, even like an AMZ bypass that is only persistent in that one process, right? So things like that would be more realistic to use in a real engagement. I would certainly not go about disabling Defender in that manner on a real system, right? So thank you for bringing that up. I appreciate that. Okay, so we have our interpreter session running a system. Let me check the help page here because I can never remember the commands. There's so many in here, and a lot of them just seem like overkill, like recording mic. Like, I don't know, it's scary. Do I have any experience exploiting Deja Blue? No, I do not, unfortunately. Let's see. We want to get some more information about this machine, right? We now have system level access on DB1. Let's see if this machine is part of a domain, right? So we can assume this is a Windows machine, of course. Sysinfo. Aha, we can see the domain is Conda, but that is only the NetBIOS name. So let's see, what is the PowerShell command to get domain name? I feel like it's just like echo and then a variable. I just don't remember it. Get AD domain, no. We'll just do it from CMD. Okay, what is, here we go. That'll work. That's it. Great, so now let's just pop into our shell and take a look. We'll run that command that we found. Maybe? Okay, there we go. Domain, conda.local. So we have system access to this machine, and it's part of an AD domain. Now, here's the big lesson here, right? That a lot of people get stuck on, especially if they're not extremely experienced with Active Directory, which is totally fine. The big thing is that I see people, they say, okay, I have system access, but I have it only in this Interpreter Reverse Shell. So what do people do? Well, they add a new local admin user, and then they, RDP in as that local admin, or WinRM in as that local admin. But something to keep in mind is that local admin is not the same as system, right? So you're kind of downgrading your permissions if you do that in this case. And if you add a local admin, that account that you add is, of course, a local account. It's not part of an AD environment. But right now, when we're running as system on this machine, we're running in the context of the actual DB1 machine, which is a member of an AD domain. So therefore, that machine account is actually an Active Directory account as well. So not only do we have full control of DB1, we actually have control of an Active Directory account. And that is a big difference there. That is what I consider to be one of the big, logical jumps here that a lot of people, I always see people get stuck here. And it's the fact that, keep in mind that system level access on an AD join machine is also an AD account. So you can start to run your AD enumeration tools like Bloodhound or things like that will bind to LDAP with your current credentials. And you don't have to know the credentials because we're not going to know the machine account password, but we can run commands as the machine account. So I hope that makes sense. All right, so next thing that we're going to do, we popped an AD account, which is system. We want to do some enumeration in the AD domain. My favorite open source tool of all time and a complete powerhouse for Active Directory enumeration is Bloodhound. If you have not seen Bloodhound, I do have a video on that as well. But honestly, I cannot say enough amazing things. Oh, not the dog. Come on. This always happens. I cannot say enough amazing things about this tool. It is fantastic. But keep in mind, again, if you were to run this in a real environment, it would be like the alarm bells are sounding. It would be flashing lights in the data center. I mean, this is not a quiet tool. This is probably the loudest tool you could possibly run. But in these lab environments, nothing else is going to give you this kind of quality information. So I'm going to install Bloodhound on our Kali device here. So let's just go back to our Kali machine. Let's do an apt install Bloodhound. I think that should install the Neo4j dependencies and all that for us, which is really cool. Awesome. Get this downloaded. And I know Bloodhound recently launched an enterprise version as well. So they're doing some really great stuff with this tool. The team behind it is absolutely fantastic. But we'll see. We should get some interesting information from running Bloodhound. It is important to note that depending on the user's permissions that you run Bloodhound with, you may get slightly different data. Not entirely different, but there could be things that it might not be able to pick up from a certain user's context, like maybe local admin rights or certain group policy stuff sometimes. Things like that can happen. So mostly on that group policy stuff, I noticed that the remote ingester, like the Python one that was written, it doesn't seem to grab like OUs and group policy stuff, unless I've just been using it wrong. I don't know. But so we want to start up our Neo4j database. So I'm just going to do that in here. So we'll do Neo4j console. We just installed that with Bloodhound. That should start up the backend database for Bloodhound. Fantastic. Should work. Okay, perfect. And then it should give us a URL we can access. There we go. Let's open that link up. Just copy and put it in Firefox. Come on now. What's going on here? Quit the funny business. It's like double clicking on me. All right, touche. Perfect. All right, so let's go to localhost on port 7474, and we're gonna have to do the first time login. It should just be Neo4j and Neo4j as the default credentials. And then we're going to be prompted to create a new password. So I'll go ahead and put a password in here. Make sure this is the right password. It is very secure. Great. So we have to do the first time password change, or Bloodhound will say like, hey, don't use the default passwords. And then you'll have to change it anyways. So there we go. There's that Neo4j database started up. And then let's just go ahead and launch the beast itself. Get Bloodhound running. Beautiful. We'll be greeted with the login page. Let's put in those Neo4j credentials that we just generated. Perfect. Perfect, perfect. So we have Bloodhound running. We don't have any Bloodhound data. So we need to run the Sharphound ingester. And to do that, you either need a session with a you need a current session as an Active Directory user so that it can, connect to the domain controller, bind to LDAP, run all those queries, or you can use credentials if you have the credentials and run it remotely. In this case, we only have a session as an AD account, which is that system level account on DB1. So we do actually have to go through, I have to go back to that GitHub page, and we should clone the Bloodhound repo to get that Sharphound ingester. So let me just go ahead and clone that. Perfect. Yeah, I'm curious to see what everyone thinks of this lab at the end, especially if this is your first time seeing it. I wanted to gear this more towards beginners, but there's certainly some tricky components in it, right? I want it to be, a little bit challenging, but not something that was like, ripping your eyeballs out challenging. All right, so let's go ahead into Bloodhound collectors. That's where we need to be. Great, and we'll see this sharphound.exe. That is what we want to run. So thankfully, Meterpreter can transfer that very easily for us. Let's just exit out of that shell. And, oh, you know what? I do want to go back in that shell. Let's just make like a C/, yeah, C/temp directory. Let's just make sure that was created properly. Yes. Okay. And then what we want to do is just upload our Bloodhound /collectors /sharphound.exe into C/temp. Great. So super easy to do. Let's pop back into our shell and cd into C/temp. And great, we see sharphound.exe. So essentially all we need to do is run this now, and we should get a lot of really valuable information about this Active Directory environment. So if you want, there's a whole help page here, a lot of different options for discovery. They have some, oh, it's not, I used -H. Oh, no, it does work. Okay, good. A lot of different options here. It can be a little confusing at first. I think if you're going to talk about the bare bones, the bare bones for doing a lot of this, of what you need to know is one of the important ones, collection methods. This is basically telling Bloodhound what kind of data do you want to collect. In our case with labs, always use all, in my opinion. That will just grab all of the data. Extra data cannot hurt. They do have some stuff to help with some stealth options, which I would highly encourage you reading some more about. It is really cool how they try to evade some antivirus systems like Defender ATP, which is all like ML based and can be hard to evade. So they have some built-in stuff like that to try to get around it. Let's see. Seems like Bloodhound is too fancy. Any robust one-liner CLI alternatives? Unfortunately, no. You can certainly do all of this stuff without Bloodhound, but I promise you it is easier with Bloodhound. If you are interested in learning some more about that, I think that the CRTP certification teaches that really well. I just took that like a month ago. You can do a lot of this with like the Powersploit repo, especially PowerView can do a lot of this stuff. Also, the built-in AD modules can, but once you see the amount of data that Bloodhound pulls, it's like it's going to take you absolutely forever to do this by hand, especially when you start looking at the ACL relationships and the delegated permissions. It is just so difficult to work through without Bloodhound. It's possible, just very difficult. So basically all we need to do here, we're just going to run sharphound with the collection method of all, and this will go through, pull a bunch of data from the domain. Yeah, certainly. PowerView is not bad. It's not as noisy, but if you're using any tool like Bloodhound or PowerView, I mean, like you're not stealthy anymore. Like that stuff's gonna get caught. So the way I look at it, go big or go home. Just run the big boy and get it over with. Now, I will say, if you run Bloodhound in like a real big environment, the sharphound ingester can take a long time to run. And yeah, I would certainly recommend having quite a bit of RAM on your system to draw some of these graphs. But I don't know. Bloodhound is super useful. All right, so we ran the data. Sharphound spit out all of it into a zip file. Now we just need to download that zip file. So we'll download c/temp/this. You like to do this stuff, live off the land style without touching the disk? Yeah. Well, yeah, you certainly can. It's, and a lot of threat actors, that may be what they're actually doing. It just takes so long. The amount of queries that you would have to do, especially the big thing is the delegated permissions. That, in my opinion, is one of the largest use cases for Bloodhound, because you see cases where companies, they give a group permission over an object, and then you get some group nesting that happens, and 10 years later, they don't realize that a certain group is nested within another group, which has delegated permissions over a different group, which can do blah, 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 and compromise the domain. You see it all the time with Bloodhound stuff, and it's hard to identify without Bloodhound. Running Bloodhound on a red team is like 30 kill streak tactical nuke. Yeah, exactly. By the time you're running Bloodhound, I wouldn't even consider it a red team engagement at that point, because I mean, you might as well just start sending pop-ups on every machine like, hey, I'm in your system. It is extremely loud, but when you don't need to be quiet, it is super valuable. And honestly, it's really valuable for blue teams. They're not trying to be stealthy, they're just trying to secure their stuff, and that's one of the big things. But anyways, now we got that zip file. Let's just upload it into Bloodhound, and it'll take care of the rest. It does a lot of pathfinding for us. So it uses pathfinding algorithms to identify the shortest path from one node to another. And a node here in the AD environment could be anything, a user, computer, whatever. So the first thing that I like to do is make a list of the assets that I have compromised. So right now we have the DB1 machine account compromised. Let's search for that. Right click on it, mark it as owned, right? This is just, it gets easier, especially when you're tracking thousands and thousands of machines and user accounts, or tens of thousands. Marking things as owned is really helpful. You can also run queries based on owned principles. So what you would want to do to try to identify a quick path is check right here, reachable high value targets. So this will say, at least based on AD delegated rights, can this account hit anything that's extremely valuable, like domain admins, domain controllers, account operators, backup operators, anything that can compromise the entire domain. So essentially, can this machine compromise the entire domain? The answer, at least from an AD ACL perspective, is no, which is, pretty common. Yeah, if you see that, that's you're very lucky. But some of the other stuff we can look at, of course, we can see all of the properties of this account. We can see where it's a local admin to, which of course it's going to be itself. We could check. Oh, sorry. This is saying domain admins are an admin to that machine. I'm sorry, I missaid that. Group memberships. What is it a member of? What groups is it a part of? Inbound control rights. So what can control this object? But in this case, we want to see, inbound control rights are, what can control this object, which are domain admins, count operators, enterprise admins, administrators, right? So things that you would expect. Outbound object control, that is, what objects can this object control? And in this case, none. So, judging from this quick glance at the Bloodhound data, at least from an AD ACL perspective, there's not much we can do. This object doesn't have control or rights over any other objects, so it's not going to help us there. This Bloodhound data will come into play later. I did run it for a reason, but I just wanted to show a brief overview of it, so when we look at it later, everything makes a lot more sense. So we have the machine account compromised. We got our Bloodhound data, which is good. It certainly will help, but we can't really use it right now. It's not going to be entirely helpful. Now, all right, give me 1 second. Now, again, this next part can be a little tricky too. So I'll say that what I wanted to do for this next part was set up group policy preferences and have like a password stored with group policy preferences somewhere. And I couldn't get that working because they don't allow you to do that with modern AD anymore, which I didn't know. So that was something I learned about building the lab, right? A little behind the scenes look. So I was thinking, how did people deploy local admin passwords before LAPS was a thing? Like, you have a use case, right, where every machine that you have in your enterprise, you want to have maybe the same local admin password. Awful idea, by the way. Don't do that. But companies certainly did that. That was like the meta for a while, And I was just thinking, how did they do that? And it turns out, if you Google that, right, if you look that up, so we say, if you want to do it by group policy, right? That's the easiest way to configure a lot of machines over AD, right? It's group policy. If you look up group policy, set local admin password, you will see some things that from a security standpoint will absolutely horrify you. At least they should, because I saw it and I could not believe this was on a Microsoft website. So, here, this is, now to be fair, this is from 10 years ago, right? I was like probably still in middle school, whatever. So they're talking about group policy preferences and stuff like that, right? And let's see, so in this they said Microsoft has a fix to prevent the use of passwords within group policy preferences. Essentially, if you store passwords as group policy preferences, they can easily be decrypted. So they're not secure. But if we look at, let's see, I'm trying to find it. Here it is, right? Now, this is from 2008. So I saw this forum post, again, from a long time ago. But they said someone was looking at how could they set local admin passwords in all their boxes. And someone said, all right, you can use group policy preferences. Okay, whatever. That was what they used to do. And they said, you can script it. And they gave a script on how to set local admin passwords through group policy. And I saw this and my mind was blown. I said, there's no way they used to do this. And, 2008, it might be a little while ago, but a lot of companies are, founded way before 2008, and if they're not keeping up with the times, their sysadmins very well may have read this article, which is the #1 answer on the Microsoft forum, and they might have implemented this. And who knows? Is it still in place? I don't know. But when you deploy scripts over group policy, the scripts are going to be stored in the sysvol share of the domain controller, right? That's how all the clients are able to access it and pull it down. And, pretty much for all the stuff in the sysvol server, not all of it, but for, most of it, anyone can access it. So any domain account can access the sysvol server and see these scripts. So if someone's out there setting passwords like this, which is the recommended solution on this Microsoft forum, you can just pull the local admin passwords from the script in sysvol. And that's where this idea came into place. And you know what? I'm happy with this one. I thought it was really cool. So, and you may see this, right? I mean, if any company deploys software over group policy and they don't know what they're doing, they could end up putting credentials in there, to script some sort of deployment, thinking that, well, it's on the, it's through group policy, but the script is on the domain controller. So I don't know. I don't know, but it is a thing, it's certainly a thing. So we can access the sysvol share in the domain controller. If we just do a dir for, we know it is, well, we can just do conda.local and then sysvol, 1/ there. And that should show us the contents, right? Boom. Okay. So exactly what we think to see. Nothing wrong here. I mean, nothing inherently wrong with the sysvol share, of course. All domain controllers are going to have it. So then we'll go into conda.local. And here you can start to see, the policies and the scripts and stuff. And we're just going to keep navigating through the sysvol share. And again, this is where everything related to like group policy and the scripts deployed there and all that kind of stuff is going to live. And any domain account can access it. Since we're running a system on DB1, we're a domain account. Here are all the actual group policies. So we can start to enumerate these. I'm going to go kind of right for where we're looking for so we don't waste time going through all these. But, we can start to look through some of this stuff, right? So we see all this. Let's keep going. We'll go through machine. And I will say it is a fairly common use case to have to run scripts via group policy. There's nothing inherently wrong with that. But if the administrators don't realize that anyone can access them, and it's not just magic group policy fairy who drops a script on there, then it can be a real problem. So, the use of startup and shutdown scripts is, not unheard of, that's for sure. But in this case, if you're using it to set a local admin password, like was recommended on this forum, you might end up with something like this, which any account could grab. And that's a no-no, right? So we'll take a look at this set password PowerShell script that was so graciously pulled from the Microsoft forum. Oh, well, we have to use type, not dir. And we'll take a look at this. Basically the same script. And we see they're, setting the password for administrator as default admin pass 1 exclamation point. There you go. So since we have access to this machine account, again, hit that sysvol and share. We can see group policy stuff. It looks like in this case, they were deploying local admin passwords with group policy, which is bad. So, the current real solution for this is to use LAPS, Microsoft's local administrator password solution. But, this is a very real thing that could happen. So now we have, local admin credentials. We just don't know exactly where to, right? We don't know where these work. So we would just start trying these in different places. So let's just try to start some RDP sessions into our other servers where they would work. This is just a form of password spraying, right? And the reason that I'm going to try RDP is because by default, administrators are in the RDP group. So if you have valid admin creds, you should be able to RDP. So let's see, we're going to use xfree RDP. What is the syntax for this? I think it's I, maybe it's V. They have some weird, it's V, yeah. I don't know what V stands for here, but anyways, it's 10.10.1, and I think, let me check my notes. I think it works on server 2. But, essentially you would just check all of the systems. You could use some automated tools to do this, like crack map exec or things like that, or whatever you want to kind of gain control here. So let's see. Yeah, server 1 is where we want to look at. So 1.30. The username is administrator. And how do you pass the password here? Is it just /p? Easy enough. default admin pass. Let's add that back there. And let's see if we can RDP it. That's promising. Great, there we go. So we have local admin access to server 1 now. So that is 4 of our 6 machines compromised. So I think that is a pretty cool little exploit path there, going from, grabbing that script out of group policy. So I don't know. Who knows? Maybe on your next pen test, check for stuff like that if you don't already. Could be an interesting thing. Never know what you'll find in the good old sysvol share, right? All right. So we got local admin access. Now, going from local admin to system is pretty trivial. There's all sorts of methods to do it. So we can essentially mark server 1. Let's just check the host name, make sure we are on the right device. Sometimes you collateral damage, you compromise a lot of stuff. It happens. All right, we'll check the host name. Yeah, server 1. Great. So let's take a look at Bloodhound again, our good old friend. And now let's go ahead and we'll mark server 1 as owned. Technically we don't have access to the machine account yet since we haven't gone to system, but we know 99% chance we could. Let's mark it as owned. Take a look at this. Now, the first thing that I would look for again is, let's see, is there a path to high value targets? No. Next thing that is a big one, especially for machine accounts, is first degree object control. We could look through like local admin access, which would be big for a user account, but we don't have credentials, so we can't really do anything except run in the context of this account. So this first degree object control outbound, that's a red flag, right? So in this case, we can see that the server 1 machine account has generic all over this server admin account. Why does it have this right? I have no idea. But, sometimes you see some pretty crazy Active Directory relationships. And this is the kind of stuff that Bloodhound will identify, that if you were trying to look through it by hand, finding this would not be very easy. Who would think to look for this, right? But Bloodhound will easily present this to you. So that is a reason why I really like Bloodhound. Also, so we know that server 1 has generic all, which is also known as full control over this server admin. Now, if you don't know what that means, you can right click and go to help. Gives you some info about it. Also the abuse info. It basically just tells you how to exploit it. So essentially what we can do is just reset the user's password. Now, if you're looking at this again from an OPSEC standpoint, changing an account password, that's probably going to look a little suspicious, right? So they give you some other options like targeted Kerber roasting and stuff like that. Mileage may vary, but the easiest way for us to do it is if we get system and we're running as server 1, we should be able to just change the password of server admin. So that's what we're going to do. Let's go back to our RDP session. And again, I'm going to do the thing you should not do in a real environment and disable Windows Defender, right? So let's see. Search for Defender if it ever comes up. And we will look at some other ways of bypassing AV in this lab as well once you start working on some of the next machines. So Windows Defender settings, I'm going to disable real-time monitoring. Let's see. So manage settings, real-time protection, turn that off. Great. So what I would want to do here is use some form of like get system script to, get system on the machine, right? So if we look for that, there are all sorts of ways to do this. Metasploit has it built in with Meterpreter. There are PowerShell scripts to do it. So many different ways. So let's see. There is Powersploit has it. There we go. So Powersploit has get system.ps1, which we can just load in with PowerShell, run that. We should have system level access. It should be good. We can give that a go. Let's see. We can try it this way. I am not confident that this script will work in this case, but we can certainly try. Just to do it, right? Just to do it. Potato family, maybe. Yeah, you could certainly do something like that would work. I think so. Let me just reference my notes real quick and grab the PowerShell command that will download a file, execute it in RAM without touching the disk. We don't necessarily have to do that because we're not doing like an AMC bypass to evade defender. We're heathens and we just turned it off. It's just how I roll. All right, let's go into our RDP session. Can we paste? Oh, I can't paste. Big sad. Big sad. Okay. Okay, just to make things a little easier, because I don't want to type all this out. That would be really painful. We're going to do it a cooler way, and let's generate a Metasploit payload, like a Meterpreter payload, and just catch it with, well, host it on an HTTP server, download it, execute it, boom. Send it, yeah, script missile incoming. I like it. I like the script missile thing. Awesome. We should, I know CW InfoSec talked about coining that term, but I would hope you would, let me use it without striking the stream. Would be greatly appreciated. All right. Let's get rocking and rolling with some MSF Venom. So if you haven't used MSF Venom before, that's Metasploit's payload creation tool. I'm assuming many of you have used it, but it's super, super useful. I would like to see Privesc while Windows Defender present. Aha, and I promise you will see it on the next box we are going to. You will see some pretty cool stuff. I don't want to spoil it before we get there, but you will see Privesc with Windows Defender present. All right. All right. Where was I? What did I just do? I don't know. I need my IP. I grabbed that. Okay. MSF Venom. The command to do this. I don't recall. All right. Let's Google, as always. MSF Venom exe payload. I guess the main thing I don't remember is the path to the Meterpreter Reverse Shell. Thank you all for putting cheat sheets out. I love it. I love it. I love it. All right. We want the payload Windows Meterpreter Reverse TCP. Windows Meterpreter Reverse TCP. All right. TCP, perfect. The format, exe. What else? What else? The local host. That is going to be our IP address. I feel like that's supposed to be 180. 188, yeah, there it is. It's right in front of me. The local port, we'll do 443. Yeah, that sounds great. And then we'll just put that into shell.exe. Fantastic. Fantastic. Okay. Now let's go into glorious Metasploit. Do we have a Metasploit session open in my billion tabs? No, that's okay. We'll just open a new tab. I wonder how many tabs I can have open by the end of this. Okay. MSF console. Let's get rocking and rolling with that. This is so we can catch that reverse shell when we run that Meterpreter payload, right? So for this, we want to use exploit/multi/handler. And let's set our payload to Windows Meterpreter Reverse TCP. Does it set our lhost to, what is it, ETH0, I think? Yeah, ETH0 should be fine. Fantastic. And set our local port to 443. Awesome. And we'll just get that running and should be fine. Okay. We have generated this. We have shell.exe. Perfect. All right. Now we just need to host this on an HTTP server, transfer it over to server 1. So to do that, we'll just use Python. Python, if you don't know, has a built-in HTTP server module. Extremely useful. I absolutely love it. So we can just do Python 3-m. What is it? Python 3 http-.server, and then the port, which is 80. So now we should just be able to go into our RDP session. I apologize in advance. Open up Internet Explorer. Makes me sick. Watch this spinning wheel for half an hour. It might load. It's trying. It is giving it an honest attempt. Okay. I think we can use it now. Great. So now we'll hit our IP, which is 10.10.0.188, I think. Is it? Yeah. Okay, great. And then we want, oh, it's because I was like, why are we seeing this Apache page? But we copied the index file earlier. I was absolutely baffled while we were seeing that. Okay, shell.exe, that's what we want to download. Trust the website. It is a very trustworthy website. Download that file, please. Okay. Open folder. And we will run this as administrator. Oh, that's sad. Okay, I think it is because we didn't specify it as a 64-bit payload. So, is it... What am I missing here? It should work. Interpreter? No. Somewhere is this listener. Yeah, it's not... Doesn't want to run that. That's interesting. I think I might just have to generate it as a 64-bit. Although... Let's see. Yeah, I can't run. Interesting. Will it run from the command line? Interesting. Okay, that's fine. Is there... Let me just Google foo again. So MSF Venom, XE payload, 64-bit. Yeah, is it? Windows/x64 shell reverse TCP. Okay, that's what we need. Ah, my bad. It happens. Perfect. Let's just change this payload here, and we'll have to change it in our listener as well. Okay, and set our payload here to match and run that again. That should be fine. Let's download it on our Windows machine again. Can't run on our PC. Why not? This is... Oh, it's not downloaded. It's 0 bytes. We download this and hit run. Did it actually generate the payload? No, it's a 0-byte file. Why? Oh, you need equal signs here. Yeah, see, that's what I was thinking. Like, the 32-bit should work on 64-bit. I had no idea why I was complaining. I just had a syntax error with MSF Venom. My bad. I'm going to be honest, I don't use this very often. So, yeah, see, final size. There we go. 0-byte final. There we go. My bad. Just forgot some equal signs. Okay, I have to add... That's fine, sure. Oh. Start that web server again. That's what I was complaining about. Fantastic. All right, sorry. Little hiccup there, not a problem. Save this file. There we go. That's the error message that I want to see. All right, now I go to downloads. 7 kilobytes. Fantastic. Run this as administrator. It's important that you do that, or else you'll have to do a UAC bypass. So make sure you run it as administrator. Command shell session 1 opened. Fantastic. Getting our reverse shell. Great. Oh, wait. This is not an interpreter session. Ah, no. No, we're going to have to generate it again. Sorry. Okay, hiccups are done. I promise. This should be the last time. We do want the interpreter session only because we're going to use the get system functionality of it, right? So let's just, one more time. I promise. I think I figured it out. Yes, there we go. Now we're cooking. All right, fantastic. This is the proper payload. We're armed and dangerous, ready to pop this machine if we start the web server. All right. Man, whoever is looking through these logs, blue team in this box, is like, what are they doing? You know, it's going to be looking awful in the logs. I'll tell you that. No OPSEC. All right, great. Let's run this as administrator. Now we should see interpreter session. Fantastic. Get UID will be server administrator 1. Great. Now let's get system. Now keep in mind the reason that we're go to background, there's a module to upgrade to interpreter. Really? I didn't know that. See, there's a little bit of delay in the stream, so I didn't see it until I already did it. But thank you. I will keep that in mind. All right, so now we got system. We do get UID. We are NT authority system. Fantastic. And in case you missed out or whatever was going on, the reason we're doing this is because server 1 system account has generic all over server admin at conda.local. And if we right click here, let's just make sure we get the correct command for abuse info. We can just change the password. Does it not tell us how to do that? It's okay. I know how. It usually tells you how. Let's see. I just want to see if it does. Usually they're good with that. Oh yeah. So here's how you can do it with PowerShell. Now there is also, you can just do it. Yeah, right there. That's how you can change the password just from command line. So super easy once we're running in the context of this user. So let's pop into a shell. Do who am I? NT authority system. Great. So now let's just do a net user server admin. Is that the correct name? Let's make sure. Server admin, yes. Server admin password 123 is what we'll set their password to. /domain. And we should have permissions to do this. Perfect. Command completed successfully. So we just changed the server admin users, which is a domain user, their password, which is fantastic. So now we have popped that account. Now, I will say you may run into some issues here running these commands. Sometimes when you spawn this interpreter session, you'll try to run commands, it won't work. Like you do who am I, and it just like won't give any output or something. And if that happens, you should try migrating your interpreter session into a more stable process. This happened to me a lot during testing, and I had some people messaging me about it. If it does happen, just do a PS to see the processes that are listed. I don't want to get into too much in depth of how this really actually works, like how, the process impersonation techniques. But I will say that essentially what we need to do is just find a 64-bit process that's running a system and migrate into it. One of the big targets for it is like SVC host. You don't have to. But if you're having those kind of issues, if you just do like a migrate into like one of the SVC hosts that are 64-bit running a system, it should resolve your issues. So now we can migrate from the one process we were in to the SVC host. It completed successfully. Go back into shell, and it's just like everything is normal. But if you were having those issues, that should hopefully resolve them. If not, try a different process with those same prerequisites. But there we go. Server admin, password 123. We have those credentials now in the domain. What do they do? Well, let's take a look. Look at Bloodhound. Let's right click on this and mark the user as owned. Reachable high value targets, none. Okay, so this cannot go to a high value target directly. First degree group memberships, 1. Member of domain users, okay, see, nothing special. Local admin rights, it says none. So Bloodhound says that this account is not local admin anywhere. I will tell you that is false. So that can be one of the limitations on the data you get from Sharpound if you're not running with an account that has local admin everywhere. Because it for whatever reason, I'm not going to pretend to know the exact details, and I don't want to give false information. I think it just didn't have the rights to query machines to see where this account may be a local admin when we ran it under the context of the DB1 machine account. Outbound control rights, none. Inbound control rights, there's a few, but what we're really concerned about is outbound. So what I would do now is take these server admin credentials and start using them other places. Now, we only have 2 machines left. We already have server 1, and which I will say that server admin is a local admin on server 1. And we have server 2, which we haven't tried yet. So let's go ahead and try to RDP into server 2 with these new credentials. All right, let's see. Somewhere in here is an RDP session. Somewhere. There we go. There it is. So we want to go into server 2, which is 1.13. User is server admin. And the password was password 123. Okay, and let's try to do RDP into there. Great. So server admin can RDP right into server 2. Yeah. So this is the last machine before the domain controller, and we can RDP in, which is great. But let's take a look. Let's open up a command prompt. And since we are RDPing in, we would assume that we have, admin privileges. It's also an account called server admin. But if we do a whoami/all, we are not an administrator on this box. Don't have administrator access. We have RDP access, that's how we got in, of course, but no permissions that would indicate high privilege user. So this is where you kind of got to switch gears. And I did this on purpose, again, kind of a behind the scenes thought processes while building the labs. Right now, if you were exploiting this, you would be in AD mode. You'd be like, I have been running through this Active Directory environment with AD attacks. What am I missing? What kind of relation am I missing? And there ain't any other relations that'll help you here. It comes down to local privilege escalation. So you have to switch gears in your mind here from AD to local Windows PrivEsc. Again, I will point you to the repo I have. Let me just pull it up again in case anyone didn't see it before. I made some mind maps for local privilege escalation on Windows and Linux. So you can check those out. Super helpful for OSCP stuff. Just in terms of getting all your thoughts together, making sure you're being consistent. Now, if we take a look at the Windows stuff, now there are some automated scripts for Windows privilege escalation, like WinPs and stuff like that, right? So you could run that and, go through trying to PrivEsc in different ways. I don't want to be here all night trying to, show all that stuff as well. And we may have some issues from it since Windows Defender is enabled as well. So you might have that issue. But if you start looking down the list, and again, knowing the fact now that none of this is really like CVE based, it's all, let's see, most basic endpoint security mechanisms will catch process injection and other similar techniques. Exactly. Yep. DLL side loading. Definitely. I certainly agree. A lot of that process injection stuff can be caught with modern AV. Although, I don't know. Yeah, that is true. But I feel like with regular Windows Defender, you can sometimes get away with it. Maybe not Defender ATP. That's a lot more advanced. But regular Windows Defender, yeah. Yeah, DLL side loading. I'm going to be honest, I haven't played around with it too much. I've done some reading on it, but I haven't played around with it too much. But anyways, going back to the local Windows PrivEsc, and talking about the theme of this is kind of no CVEs, just kind of like bad administration, lazy admin kind of stuff, misconfigs. The one thing that we're going to focus on, the method is credentials from the command key. So let's take a look at this RDP session. And let me make this bigger. I'm sorry, I totally was blanking on that. Let's see, properties. Let's bump this font up. I know I'm young, I got young eyes, so I forget sometimes. Just kidding. Let's see. Just don't want to have all that text in the background. This will be fine. No, stop. There we go. This is not what I want to do. I keep clicking that tab thing. I'm in the command session. There we go. Finally. Okay. So we have this session, right? And if we do a command key, slash list, we'll see credentials that are stored in the local credential vault. And this is sometimes done, well, the way this comes about is if you do a run as with save cred enabled. So if we just look for some Microsoft docs, run as save cred, they will tell you don't do this, but they do give the option to do it. Let's see, I want the actual Microsoft docs. I guess they're just bad at SEO. Okay, yeah, so let's look at the run as and the save cred option here. Okay, so this option will indicates if the credentials have previously been saved by the user. So indicates if the credentials have been previously saved by the user. So essentially, if a user were to run a command with run as, right, and save their credentials with save cred, then anytime you were to go back and try to run a command as that user, any command, you could run them with those saved credentials of the user. So this is kind of like, you can think of it like limited sudo access in a way on a Linux device, right? Where you're a low privileged user, right? And maybe it's like the IT guy knows that this one person keeps running this certain command and they need to keep coming down and giving their admin cred. So they get frustrated. So they go, all right, I'll do a run as and do the save credentials. And it just can't, it saves them the credential vault. You can't pull the credentials out necessarily. I think you can in some ways, but I don't recall exactly what's going on. I think Mimikatz can though. But maybe they save their credentials with run as so that a user can use their credentials, the higher privilege credentials, to execute some sort of command, not knowing that this allows those credentials to be saved there indefinitely and run whatever command they want, right? So let's take a look back at our RDP session. So if we take a look here, we can see that we have these kind of accounts here, which you'll see on the devices all the time. It's not really anything to worry about. But the one that stands out is this domain password for IT manager at conda.local. So let's take a look at Bloodhound for IT manager. So look at IT manager. We know we can run commands as this user, and let's just test that out real quick. So let's go. Sorry, I'm like popping around tabs. We'll do a run as / save cred with the user of IT manager. I'm just going to copy and paste this. Now, it is important to specify the username exactly as it's shown here. And then the command, we'll just do like a Powershell.exe. Great. So we're running Powershell.exe. Let's make this a bit bigger. And here's where you're going to get into your privilege escalation with Windows Defender enabled, right? So let's see. We have this running. We do a who am I, conda.local / IT manager, okay? Who am I / all. We can see this user is a local admin here, right? But if you look at our privileges, we don't have actual admin token privileges here. And that's a UAC thing, right? We haven't gone through UAC to actually perform admin level stuff. So let's take a look. We can start to execute, and this is what we can use to lead to compromising server 1 completely, right? Because we know this user is a local admin, but we can't actually do admin things with those credentials. Let me just grab my notes real quick. And let's grab that PowerShell command we've been using. Okay, it doesn't want to paste. No worries. So let's just do a what we were doing to disable Windows Defender. We'll do set mp. Oh, I hit tab. That was a mistake. It always takes a while to buffer after you hit tab. At least on these machines. They don't have much RAM or anything because I tried to optimize them a little bit for cloud hosting. So, okay. And then we want to disable real-time monitoring. There we go, and we'll set that to true. And then we'll also give it the verbose flag. Try to do that. We don't have enough permissions. Why? We're an admin. Why can't we do this thing that only requires admin rights? Well, we don't actually have an admin token again because of the protections that UAC brings into place. So in this case, in order to actually gain admin control of this box, we need to do a UAC bypass. And there's a ton of common UAC bypasses out there, right? A bunch that you can work off of. But a lot of that's going to get caught by Windows Defender. So you're going to run into some issues there with doing that, you know? So let's take a look. If we were to run some common scripts for UAC bypass, Windows Defender is just going to axe that. So let's try to prove that. I'm wondering why I can't copy paste. It does kind of suck. Let's see. Can I copy from here to the RDP session? Oh, I can. Okay, no problem. I was copying from my host machine to the RDP session and it doesn't work. That's fine. I understand. So we want to do a UAC bypass here to try to get actual admin privileges, right, with that admin token. So let's see. There is a bunch of scripts out there for UAC bypasses. Meterpreter has ways to do this. Our version base, can we see the version? Sure. Yeah, let's take a look at the version here. So we'll do a winver, server 2019, 1809. Now, a very common UAC bypass is like FOD helper, right? That's a really common one. So if we just do like a UAC bypass, UAC bypass, FOD helper, Powershell, we can take a look at some of the scripts that are here. And let's see. I think this one should work. Yeah. Great. But I think one of the things that we're going to run into is Windows Defender blocking it. But I do want to show that actually happening. So let me just grab this PowerShell command. We will use the, this is kind of like a liaison, so I can copy and paste. Or maybe I just can't. There we go. Great. Sorry, I just don't like to keep typing out that PowerShell command to download and run stuff in memory. So let's just pull this from GitHub. And again, you know, with OPSEC in mind, if you were just pulling these straight from the GitHub repos, that's certainly a no-go. It's not going to work. Now we'll just grab this string and paste it in here. So we would, hopefully here, we would be, you know, loading this FOD helper UAC bypass script into memory and running it. Let's try to do that. Oh, it actually worked. So I'm surprised that worked. It apparently did not get blocked by Windows Defender, which I'm pretty shocked by that. Let's see. Let's try to run our FOD helper UAC bypass. So I think all we have to do is, let's see, where is it? Just run the command FOD helper UAC bypass since we've loaded that in. So let's go ahead and do that. See if it works. Oh, I am. Wow, I think I'm really surprised. I feel like, let's see, do who am I slash all. It actually worked. For some, when I was going through testing, that was getting ripped from Defender. So that is interesting. So that seemed to actually work, which is not the expected behavior. I mean, I'll take it. I will go through and show the other stuff with the AMZ bypasses, right? That was the intended method. I don't know why Windows Defender isn't catching it, but hey, whatever. So we have this. I will show, like I said, the AMZ bypass stuff, which is how this was originally going to be done. So we'll just spawn this PowerShell session again. From this one, we don't have the admin tokens. So, you know, we don't have the actual admin rights here. If we were to go through and try to load Mimikatz here, let's see. Let me go ahead, grab that PowerShell command again just to load invoke Mimikatz. invoke Mimicat should certainly be caught. I'm just using this to hopefully paste. The copy and paste is being really weird to this Kali instance from my host. Not sure what's up. Weird. Okay, great. So we have this now. And let's paste this in. Man, the hardest thing about this lab is copy and paste. All right, so if we go to load invoke Mimikatz in here, AMSI should stop this. Yeah. So it says this script contains malicious content. It's been blocked by AV, right? And yeah, CW info site. I saw that too. That was a little weird. We might have like some sort of race condition there where it was like it executed that new command process and then it got blocked and died. But I don't know why it didn't kill the child process. You know, yeah. I mean, hey, yeah, exactly. When they review the CM, but I guess it's a race to domain admin now, right? They got to catch us fast. So we're already on the way. But yeah, I am a little baffled that worked, but sometimes you just get lucky, I guess. I don't know. So anyways, yeah, we go to download Mimikatz. It says absolutely not, right? Because AMSI is in place. If you're not familiar with AMSI, let's just take a quick AMSI overview. Basically, this is Windows anti-malware scan interface, right? This is what allows any program to communicate directly with the antivirus software that lives in the machine. It is vendor agnostic, so it doesn't matter if it's Defender, it can be whatever. It's essentially just a bunch of functions that programs can call by loading in amsi.dll, and it allows the programs to be like, hey, scan this file with whatever AV is on there. And then, AMSI will be like, hey, this is clean, or hey, this is malware, and the program can determine what to do from there, right? That's a really basic gist of AMSI. It's hooked into PowerShell by default, or like Visual Basic scripting and stuff like that. So when we try to run that PowerShell script and load that into memory, even though we're not touching the disk at all, it gets passed through AMSI first and gets scanned with Defender, and Defender says no. So PowerShell says, hey, I'm not going to do that. And hey, I didn't even realize I was on Infinite Login's blog. He always pops in one way or another. All right, sorry. Great. So now there are a bunch of publicly documented ways to bypass AMSI. And quite honestly, a lot of the public tools are extremely effective. So one of my favorite ways to do it is going to amsi.fail. Great website. In my experience, a lot of the ones generated from here actually work with modern Windows Defender, which is awesome. Basically, what it says, it generates obfuscated PowerShell scriptlets to break or disable AMSI only in the current process. Again, this goes back to like disabling Defender on the machine. You don't necessarily want to do that, disabling antivirus on the whole machine. These AMSI bypasses are only disabling AMSI for the current process. So it's not really that dangerous, because as soon as your process dies, like your PowerShell session ends, the AMSI bypass is gone. It doesn't affect anything else besides that current PowerShell window. The one that I have the most success with here, I'm not going to go too into depth about it, but it is Rasta Mouse's AMSI bypass, which has to do with AMSI scan buffer memory patching. I want to pull up his blog about it. I feel like we can get to it from here. Yeah. His article on this, seriously, I think I can put this in the chat. Let me do that if I can. Can I send links, or is YouTube going to be like, hey, there we go. Okay, I can. I would highly recommend giving this a read after the stream. He breaks it down in a really easy to understand way. Essentially, the method that we're going to be using that he has here is that when amsi.dll gets loaded into memory, we're going to find the memory location of the AMSI scan buffer function and overwrite it in a way that we always make it return saying that it's a clean file. So, he breaks it down all the way. You can read exactly how he went about discovering this and generating the code for it. Essentially, it just comes down to putting this little bit of assembly in so that it, essentially, let's see, where is it? It always returns AMZ clean result. So always returns 0, right? Which is typically AMZ clean result. So again, go through and read that, but that's the AMZ bypass we're going to be using. I have the most luck with this out of any of the methods that are generated with AMZ.fail. And it tells you what method it is here before you use it. So I'm going to keep hitting generate until I see Rasta Mouse's one here. It usually doesn't take that long. There we go. Rasta Mouse's AMZ scan buffer patch. The other one certainly can work. This one, just for me, is certainly most effective. So we paste this in, and notice, everything completed just fine. We get no Windows Defender complaints. But right now, that went through and actually did the AMZ scan buffer patch, and anything we run, as long as we don't touch the disk, should not be caught by Windows Defender. And we can prove that by downloading invoke Mimikatz and running it in memory again. The same command that just got blocked by AMZ a moment ago is not blocked now, right? So that's what we should have had to do for the UAC bypass thing. I don't know why it just was like, I'm going to block it, but also let it run. That was kind of hilarious, not going to lie. But there we go. That would be the thing. And then you would load the UAC bypass. It might still get caught the same way because it does touch the disk. But either way, it should work and do exactly what we just saw there. But here we have Mimikatz loaded, and I can prove it by running, invoke Mimikatz. Now this, I don't think this will get caught. I don't think it should, because we bypassed AMZ, and it shouldn't hit the disk in a way that would get caught by AMZ. Right, it can't get the handle on memory, but that's fine. Just because we're not running it as an admin in this PowerShell window. Now, I will say, while you may bypass AMZ, and AMZ might not give you the boot when you try to load it, endpoint protection will still be wondering why a process is, going to be grabbing the memory of LSAS or something like that, right? So just that pattern of behavior of accessing another process's memory, specifically LSAS, pretty much any endpoint protection is still going to be like, stop what you're doing, or throw an alert, or, you're going to get alerts in the CM. It's, but it will, at least in the moment, work and get you past Defender. We're not really red teaming this lab. We're just pen testing and trying to get through, So yeah, there's that. There's our AMZ bypass. There's our, what we should have had to do to get a UAC session. Now, where's our actual admin window? Here it is. Cool. So here's our window that we have that's actually running as Conda IT Manager and has all the proper admin tokens. So let me just increase this font size. How about 36? That is massive. You know what? Let's see if we can make this bigger. Yeah, like, why is the RDP window locked to that size? That's awesome. Okay. We'll do 24, should be fine. Yeah, hopefully we can read this. Okay, so this is actually admin, 5 boxes completed. Only thing left is a domain controller. We are in the home stretch here. We are almost all the way through the lab. It's been quite a journey so far. So, good. We are all set. Yep, this does have all the correct privileges. We are running as IT Manager and AD. Let's go back to Bloodhound. IT Manager. Let's see. Reachable high-value targets, 0. Okay, so still, we don't have an exact path to get to domain admin or whatever. Outbound control rights, 1. What can we do? All right, so we're running as IT Manager, which you don't necessarily have to have gone through that UAC bypass, gotten the admin token to do this next part, right? That was just to go through and get actual admin control of that box. You don't need to do that for this next part of moving to the domain controller. So we can see that the IT Manager can add members to domain service accounts at conda.local. So for all intents and purposes, we can assume we can add ourselves there. That should be no issue. From there, domain service accounts, reachable high value targets, 0. Scroll down. Outbound control rights. First degree object control 1. What can domain service accounts group do? Aha, they can get changes and get changes all over the conda.local domain. That is bad. That is very dangerous. You may not have heard of this before. What you may heard of it referred to as is DC sync rights. All right, so if you go to the abuse info, it will tell you if you have both get changes and get changes all privileges, you can perform a DC sync attack using Mimikatz. So, and here's the exact command to do it. Essentially, the DC sync, what it lets us do is, this is how different domain controllers could basically replicate and synchronize back and forth to make sure that they have the most up-to-date data. What this means for us is that we can extract any data that a domain controller may have by trying to synchronize with the domain. For exploit purposes, we can basically just request all of the NTLM hashes for every user in the domain, including domain and enterprise admins. So once you have DC sync rights over a domain, that's game over. You've won, right? So let's go through this final stretch and pop that. So first we need to do, add a user that we have control of to domain service accounts. Should not be too hard, right? So let's go back. Again, you can hit help, abuse info. It'll tell you exactly how to do it. So here's a command, net group, the group name, add /domain as well. So let's go into here. Let's go into, let's see, where's our admin window? We don't need to be running as the actual, with the admin token here. We don't have to, but we can, it's fine. So let's do a net user. Oh, no. Net group. I'm blanking on the command. I just read it. Yeah, net group name, username. Okay. What am I doing? There we go. Net group domain service accounts. And let's just add ourselves, IT manager /add/domain. Command completed successfully. But if you do a who am I /groups, you'll see you're not going to see that group there. Why? You need to start a new session. So it won't take into effect until you just simply create a new session. So now we do a who am I /groups, and we should see domain service accounts somewhere in here. Built in. Am I missing something? Maybe we just have to re-log in general. I thought we could just start a new command session. It's possible that we have to re-authenticate to the machine. Okay, not a problem. No. So let's just log out. And now when we sign back in, that should work. Sorry, very anticlimactic there. All right, get back in. Okay, and let's see. Open up our command prompt. We don't have any of our command history. That sucks. That's okay. Do a run as /user IT manager at conda.local. Save cred and PowerShell.exe. Great. Let's do a who am I /all. Domain service accounts. There we go. Yep. So just a quick login, and we are in that group. Now we just have to actually exploit the DC sync stuff. And we can do that without being administrator on the box. What we can do is just do, we do need Mimikatz for it, right? And we won't disable Defender here. We'll just do our AMZ bypass again. So let's paste in our AMZ bypass. Maybe. Great. Okay, so we got our AMZ bypass going, and then we just need to load Mimikatz again, invoke Mimikatz. So let's go grab that. Fantastic. And again, like I said, we don't need admin privileges. We don't even need debug privileges. We shouldn't, because this is, based on AD permissions. It has nothing to do with the local account, the local permissions. And then let's go back into Bloodhound, where it gives us the exact ways that domain service accounts can do DC sync. So we get that correct command. So let's go to get changes all or get changes. Either should work. Go to help, abuse info, and here it is. So this should net, the net result of this should be getting the NTLM hash for the domain admin. All right, so let's go back and we should do an invoke mimikatz dash command. And it is LSA dump DC sync / domain is conda.local. The user we're going to target is administrator. And I believe you could omit that user flag and just grab everything. We don't really need to do that though. And I think that'll work. I think we should add single quotes around this as well. It gets a little weird with parsing it as multiple arguments if we don't. And hopefully we should get the domain admin NTLM hash from it. Perfect. That's what we like to see. So DC sync writes, right, we requested a form of replication from the domain controller since members of this group, which we added ourselves to, had the rights to do that. We see this administrator user object, which is our domain admin. Here is the NTLM hash of the domain admin. We're almost there. This is the home stretch. Here we go. Last thing we need to do is pass the hash and log into the domain controller as administrator. We could do this with RDP as well. I'm going to show a different tool off just because we haven't talked about it. We're going to do a gem install evil winrm. This is a tool that will allow us to log in basically with remote PowerShell. It is extremely useful, really some great stuff built into it by default as well. So now we can just do an evil winrm. And the great thing is that it can do pass the hash attacks. So just paste in that hash. The user is administrator. And the IP that we're targeting is 10.10.1.100. Go ahead and enter invalid hash format. Doesn't like that. Did we copy it wrong? Yes. That's always the problem. There we go. Establish the session. And let's do a whoami/all. Let's see what groups we're in. This is the sweetest part. Enterprise admins, domain admins. We've done it. That's the entire lab. It is complete. That is the entire walkthrough for the entry-level pen testing lab that I made. Let's check the desktop folder here. There is a little root.txt in here, right? Nothing crazy, but basically just a thank you for doing it. That's it. That's the whole lab. Like I said, it was geared towards more, entry-level pen testing like the lab implies. Should be some things that were a little bit challenging in there, but I really want it to be like a learning experience for people who have never targeted anything more than like a hack the box machine before, right? So, kind of like what your first hack the box pro lab experience would be like, so that's it. That's everything for it. I hope you all enjoyed it. Now, if you do go through and root all of it, I would encourage you to go back and take a look at how I actually configured all of those things and see how those misconfigurations came into be, especially the Active Directory stuff if you're not familiar with it. And it's a great way to learn. Go back, kind of reverse the, reverse the lab engineering and see how it was done. See, pass the hash is cliche. We crack with rainbow tables. Yeah, you certainly could do that. That's for sure. But for all intents and purposes, pass the hash will work for us today. But there's certainly a ton of rainbow tables you could grab to rip those NTLM hashes like nothing. You might have some issues with this hash though. I think it's like 40 random characters, but there we go. I'm excited to hear some feedback. If you do decide to go through the lab after or whatever, definitely Let me know what you think. And please spread the word. If you know other people who may be interested in a lab like this, go ahead and check it out. Share this with them. I think the fees for it are pretty minimal, so access to it is free. I don't make any money off of it at all, not a penny. The only thing you're paying for is AWS hosting, which I think the storage is roughly $10 for a month if you were to never turn it on. During runtime, I think it's like 47 cents an hour of running. We ran through this lab knowing the path in about 2.5 hours. So, it'll vary. The cost of it will vary depending on how long it takes you, and your experience level and that kind of stuff. But overall, it's a pretty cheap price point for this lab. I think so. It's as cheap as I can possibly make it, right? But that's it. I'm going to sign off. If you have any more questions or anything like that, please hit me up on Discord. I'll be on, my server all the time. And thanks for those of you who tuned in and asked questions, interacted. +1 for the AD foothold. Looking for Stefan Sisfall favorite tricks. Yeah, thank you. I like that one too. So appreciate it. All right, I'm going to head out for the night. But again, feel free to hit me up on Discord if you have any more questions about the lab. Thanks for watching. I'll see you next time.